There you go. Okay, objective. Once again today we're talking about factoring polynomials. Okay, so it's day 2 of this. First of all, the hard part about factoring polynomials is figuring out which one it is. Luckily we did this one in our warm-up. That's going to help. I will put a little something up here, a little star, and I'm going to highlight it to always, common factor first. If you can. Always common factor first, if you can. Now, a lot of problems you can't common factor, but if you can common factor, do it. Okay? Because if you can common factor, then it makes the problem smaller. You with me?
Yeah.
And I mean, you know, life is full of problems, but if we can make our problems smaller, it's going to be better, right? In math, if we have to factor, if we can common factor it, it makes it smaller. We got easier numbers to work with, okay? But the problem is, number one, our first example, yeah, you can't common factor. They have nothing in common, do they? 8, 125, x cubed, there's nothing in common. But it is a perfect cube, right? So it's going to be the cubic ones, and we're going to use our a cubed minus our b cubed formula, right? I recognize that 8 is a perfect cube because 2 times 2 times 2 is 8. So I'm going to rewrite my problem as a 2x cubed, okay? And 125 is a perfect cube. 5 times 5 times 5. Everybody see that? So minus a 5 cubed. Now I like to write them in parentheses. You don't have to. I put them in parentheses because then I can see that what I want is a is going to be the 2x and the b is the 5. And then I'm just going to plug them into my formula, okay? The formula I'm going to use is the one that's on the board, right? It's going to be the a minus b times the a squared plus ab plus b squared. And I will leave that up there. That's not going away because I don't expect you to memorize this, but it's nice to have it up there. So I've identified that it's a perfect cube. I made sure I have a cube here, something cubed, and I made sure to have something cubed here. So that means my a term is 2x and my b is 5. And we're just going to plug it into our formula, okay? So, parentheses, the answers, parentheses, a minus b, right? A minus b. Well, a is the 2x minus the b. Okay, my formula. Here's my formula. Parentheses, a squared. Now, a squared, if I square this, a squared is like 2x times 2x. A squared is a 4x squared. Okay, I squared this term, and then plus ab. Multiply these two. That's going to be a positive 5x. And then plus b squared. 5 squared is a 25. And that's all you can do. You can't factor it again. You're done. Okay.
Yeah, well, yeah.
Yes, it is. It's Monday morning for me too. Thanks, Susanna. Yes, it is. Till next. Because I multiplied that times that. Thanks. Okay, example 2. How am I doing? Okay, am I going slowly enough?
Yes.
Okay, when I look at example 2, always common factor first, if you can. Well, I recognize that there's a common term, right? There's a common x. So if I take out that x, what's left inside? Well, this was x cubed. I took out an x, so I'd have an x squared. This is an x squared, I took out an x, so I'd have an x left over. 2x, I took out the x, so I'd have just a minus 2. Now, this can be factored again. We've done trinomials in geometry. We know I'm going to use 2 and 1. I'm going to use a positive 2, negative 1. Positive 2, negative 1. Positive 2, negative 1 will make a positive 1. So this x is still there. Parentheses, parentheses, right? We're going to trinomial factor x, okay, cadence, right? We're going to go x plus 2 x minus 1. That's completely factored. And this is what we did last year, right, in geometry. We can do that. How am I doing? Slowly enough? All right, I'll slide it up. Example 3. Well, I got an x to the 4th. I cannot common factor, but I know that x squared times x squared times x squared makes x to the 4th, right? So I'm going to go parentheses, 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 parentheses. I'm going to go x squared. That'll make x to the 4th, okay? Now, I'm going to think about what are the multiples of 4? Well, 1 and 4, right? Or 2 and 2, but I need to make a 5. 1 and 4, right? So Isaac's, and they both have to be negative. Isaac's right, because a negative, so negative times a negative is positive, so negative 1 and negative 4. Nice job, Isaac. Awesome. Now you'd think you're done, and normally we would be done, but these two can be done again. Okay? Don't put the phone away. You need to be paying attention. Oh. All right. So. Seeing things. Yep. So let's factor this again. Let's go x plus 1, x minus 1. And then what about the x squared minus 4?
X minus 2, x.
Nice job, Isaac. Okay, so this polynomial, this is the difference between geometry factoring, which is fairly simple, and algebra 2. You see the difference in difficulty? These are a little bit harder, aren't they? All right? Slide it up. Now, example 4. 4 terms, what are you going to do? 4 terms, what are you going to do? Okay, group them. We're going to group them, right? I'm going to put a 1 right here. It's going to help me out. Group them. Okay?
No, Mr. Davis. For example 3, will that just be your final answer?
Yes. Okay, here we go. Example 4. Group them. Boys, what do they have in common? What do the first two have in common?
2 x's.
X squared, right? X squared. So take out an x squared, and I'd have left over an x minus 2, right? These two don't have anything in common except, watch, this is a trick. We need this. We need somehow to make this. We need to make this. So if I take out a negative, if I take out a negative 1, it's going to change signs. I'm going to take out a negative 1. I'll have an x minus 2, okay? Okay, now, do they have something in common? Sure,
Yes.
right? By taking out that negative 1, I was able to make this term, right? So I take out my x minus 2, and what am I left with?
X squared.
Minus 1, okay? Now, I'd normally be done, finished, move on to the next problem, but that problem can be done again. In fact, we just did a problem like that, didn't we? That problem can be done again. Yep, so I'm going to have my x minus 2, and I'm going to go my x plus 1, x minus 1, and now we are done. Okay? It's a good day to do this again. You guys agree? We need some more practice on this. Okay, return the page?
Wait.
I will.
Thank you.
Yeah. Okay, all right. Now, example 5. We've got a couple more to do and we're done, all right? Example 5. What do you see? What do you see?
2.
Okay, I see a common factor of 2. What else do we have? X to the 6th. Good. Okay? So, if I take out a 2x to the 6th, I'll have an x to the 3rd minus 8. Okay? Now, normally I'd be done, but I recognize something. I recognize this.
Wow.
Do you see this?
Whoa.
Whoa. So if I rewrite what I have, 2x to the 6th, and make this x cubed minus a 2 cubed, you see that? Then I can let my a be my x, and my b is my 2, right? And then I'm just going to plug it into this form, right? So my a is going to be my x, and my b is my 2. I'm going to plug it into my formula, a minus b times my a squared plus my ab plus my b squared. I'm going to plug it into that formula because I have a cubed minus a cubed, right? So 2x to the 6, I'm going to go x minus 2 x squared plus 2x plus 4.
Then you could redo that.
You can't.
You can't.
No, because that won't factor. Because multiples of 4.
B would just be 2 and you don't include the exponent.
Oh, 2 squared is 4, right?
In the beginning. 1 over. There.
Right. So that is the x minus 2 is the a minus b.
Yeah.
Okay. Okay.
But you included.
Okay. All right. Got 2 more problems to go, guys. Here we go. Example 6. What do you see? Jay? What do you see? 2x to the 4th, right? Okay. So if I take out 2x to the 4th, what's left inside?
13, wait.
X to the 2nd minus 13x plus 42, right? Right? What times what makes 42? 6 and 7. Why is 6 and 7 such a good combination?
Because of the negative.
Yeah, let's go -6, -7, right? So we've got my 2x to the 4th, x minus 6, x minus 7. Okay? Now, 7. 2 ways to do it, okay? If it's a factor, we get a remainder. We're going to get a remainder of 0, okay? We could divide, but I showed you a trick, which is faster. If we use synthetic substitution and our answer is 0, it is a factor. If we put in our number, if we put in x equals -1, and we get any other number besides 0, it's not a factor. It's just a remainder, right? So let's do synthetic substitution. Synthetic substitution. So I'll go a -1 cubed minus 13 times -1 minus 12. And I'm just going to use my calculator because, well, I don't really need I can do this without the calculator. -1 plus 13 minus 12, and it will be 0.
Dang.
So yes, it is a factor.
So is that easier than
Division?
What?
Yeah, if I did the synthetic division, Isaac, I'd have to go -1. I'd go 1, 0, -13, -12, right?
Yeah.
And I'd be looking for my remainder, and I know my remainder is going to be, I know. So if all I need to know is whether it goes in evenly, I don't need to really divide it, right? Right? It's like saying, does 5 go into 20? Yeah.
Yeah.
It's a good answer. I never said what is the answer. I just said, does it go in evenly? Yeah, right? Okay, now.